Today I am going to demonstrate for you the lab that you read over on Wednesday. Do make sure that you have double checked that your data table has all the correct information in it. You should have an entry for copper, for the empty screw top test tube, for the screw top test tube with silver nitrate, for copper, after, because we're reacting it, entry for an empty beaker, and then for the beaker with the silver crystals. We're going to do the first part of the lab today. I'm going to model that for you. And so our very first step is to get a piece of copper and to take its mass. Notice that I am not touching it with my hands. Remember that whenever you touch a piece of metal, or really anything, that you leave a tiny, tiny trace of body oil on it, and that can prevent the reacting. So I am bending this in half so that it will fit neatly into my, hopefully neatly into my test tube. It's just copper, so pretty harmless, but even you know what happens to pennies, like after you've held them. So my balance says 0.00, so let me stick this on. I'm gonna go ahead and add my glasses, technically in just a minute. I'm gonna be working with chemicals. Sorry, my balance needs to warm up. So the mass of my copper is 0.67, 0.67. So you may want to add that to your data table. So the second thing that I need to take a mass of is my screw top test tube with the lid. So the mass of that is 27.43. The next thing I'm going to do is add a little silver nitrate to this. If we had been in class, this would have been one of the things that I had actually added for you. Silver nitrate is tremendously expensive. Let me get my spatula. And so typically this is one of the few chemicals that if we'd been in person, I would have measured out for you, just so we would have enough to get through 4 classes. So let me see if this went up enough. Try to get between 1.5 and 2 grams. So we're at 29.11. Yeah, that'll work. So the reason I take both of these masses is ultimately I want to know how much silver nitrate I got. So the difference in these, my test tube with the silver nitrate and the test tube, if I take one minus the other, I will get the mass of silver nitrate. My next step is to add some distilled water to my screw top test tube. One of the questions I asked you in the pre-lab was, how come we don't need to know the mass or the quantity of water? Well, water isn't actually a part of this reaction. It's just what we dissolve the silver nitrate in so that it can react. This is actually an endothermic dissolving, so as I get this to dissolve, I can feel it getting colder. It takes energy to dissolve. It doesn't always that way, it kind of just depends on the salt. And once this is dissolved, I now have my screw top test tube with silver nitrate dissolved in water, and I have my piece of copper. Hold on just a second as I go get my, I knew I'd forget something. I forgot my test tube rack. So once I've got this dissolved, I'm now ready to add my copper to it. Notice I'm still being careful not to touch that. And now I'm just going to let this sit and react. So I am going to also set up my phone for a time lapse. So while this will take a little bit of time to react. But as it's reacting, basically the silver ions that are in solution are taking electrons from the copper that's in a wire form. So that we're starting out with copper. And we put a little S to indicate that it's in a solid form, solid copper, right? And then we're adding it to silver nitrate that has been dissolved in water. And the symbol for that is AQ. It simply means the silver nitrate was dissolved in water. And what we're looking to make is silver in the solid form. And then as the copper dissolves, it will go into its ionic form and make copper 2 nitrate, which also dissolves in water. So as we actually look at the test tube, what we should notice is that gradually the color of the water will change. So be looking for that to see if you notice any changes in the color of the solution. And I'm going to pause this for just a minute so that we can just wait for it to react. Okay, so about 10 minutes have passed. It's probably a little hard to see, but you can see that my solution is now changing color. And I'm going to bring this up close so that you can see what's happened to I don't think that's going to be very clear, but you can see what's happened to the copper. It is no longer just exposed. You can see where it was leaning against the glass. You can still see a little bit of the copper, but on the surface of that wire, I have silver crystals forming. So what I'm going to do now is knock them off so that more copper is exposed, so more reaction can happen. I'm just going to do a little knock like that. And at this point, the reaction will continue a little bit more, but we've probably got the bulk of our crystals formed. We'll see more form. What I need to do now, though, is to measure the mass of a clean beaker. So I have that ready. So I am now at, my clean beaker weighs 28.30 grams. I need to know the mass of that beaker because ultimately that's where I'm going to collect my silver crystals. And I want to be able to let them dry and see how much they weigh so I can see how much silver was made compared to how much copper reacted. So thinking about my copper wire, what do you predict is going to happen to its mass? Remember, it was 0.67 grams to begin with. Do we expect that to go down or to go up? Think about that for a minute. Try to knock a few more crystals off. So in just a minute, I'm going to use a process called decanting. Decanting as a process has been around a very long time. And the idea behind decanting is that normally, if you have a solid and a liquid and you pour it, for example, here's my, so this is my beaker, and here's my solution, and my solid is down here, right? Well, when I'm pouring this out, if I'm trying to separate the solid from the liquid, I don't want the solid to also pour out. So generally when you pour, what happens is you get this back current as it pours and it kind of stirs up that solid. Well, if instead of just pouring out the liquid, you pour it down a glass stirring rod into another beaker, what happens is instead of, it actually just gets rid of that back current and it makes it where as you're pouring, most of the solid will stay behind. So it's actually a pretty easy process. And I'm going to be doing that in just a second. I still have a little bit of silver crystals forming, but just to let you see it again, you can see that as I knock it off, the silver is falling down to the bottom. sorry that that's not focusing in more clearly. I am going to do a time lapse of another one. So I still have a tiny bit of silver forming, and generally you do want to wait and let it react as long as possible because you want to use up all of the silver nitrate that is in solution. What I found after years of doing this is that it doesn't always happen. I think that sometimes the copper also starts reacting a little bit with the water and oxidizing, and that kind of competes with the process of making silver crystals. But you can see that my solution now is definitely a different color. Let's see the contrast there. So the first thing that I'm going to do once I believe the reaction has stopped is I am going to knock off my silver crystals one last time. And then I need to get everything in here into my beaker. So I'm going to kind of just do a very quick inversion and shake. And there's still some silver crystals and a little bit of solution left behind. So I am going to use my rinse bottle to get everything to the bottom. And I'm just going to keep doing this until I make sure that I have all of my silver crystals out. Let me get my glasses down here so I can see what I'm doing. And I think that's it. Let me do one more last quick rinse, but I think I've got all my crystals out. So I'm going to set this aside so that I can clean it later. So now I want to get the copper out and clean it off as much as possible so that I can take its mass. So I'm going to pick it up with my forceps and then use my rinse bottle to get the last little bit of silver off of it. Sometimes what you find is that there's a little bit of silver that stays stuck on. So I am going to get a second pair of forceps. That is what we call the tweezer looking things that we use in science. And I'm just going to kind of do a little bit of scraping to see if I can get a little more residue off of my copper. Remember that my ultimate goal is I really want every little bit of silver off of this and down into my beaker. You may remember in the procedure, it said that once you have your copper clean, that you are going to dip it in acetone. You guys know what acetone is commonly known as? Well, where you commonly see it in everyday life. Probably if I let you smell it, you would recognize it. But acetone is the substance that is used in some nail polish removers. So I'm going to throw just a little acetone in here. And then I'm going to dip my wire in it. Acetone, as you may or may not recall, actually evaporates super quickly. So it does help dry this wire off even more. But I've dipped it in, and now I'm going to wipe this off one more time with my paper towel. Make sure I can't scrape any more of the silver crystals off. There's just a tiny bit of residue. Okay, so now I'm going to weigh this one last time. This is my copper after. And my mass is now 0.39 grams. Now I am done with this piece of copper and I can toss it. So the second thing I need to do though is I need to get my silver crystals separated from this copper nitrate solution. So the way that I'm going to do that is through the process of decanting. Once again, decanting is pretty straightforward. You're simply going to put a stirring rod into a beaker. We call this the decant beaker because it's catching our decant. And we're going to pour our solution down that stirring rod. Once again, what this does is it reduces the back current so that the vast majority of your solid will stay behind as you slowly pour out the liquid. And there's my cup, my silver. You can kind of see it, hopefully. In the directions, it says to rinse it a few times. This rinse bottle is super handy because this nozzle really focuses a stream of water. But for my purposes now, I don't want that stream to be as strong as it can be because I don't want to break my silver crystals up. So for my rinsing process, I'm just going to pour a little liquid in, let my silver crystals settle again, and then decant. And then a little more water, one more rinse. It's really important to get all of the extra copper nitrate out of this so that I don't accidentally have some copper nitrate in here when I end up weighing my silver crystals. Sorry, it's not quite settled yet. Let me give it a second. Don't rush, Miss Karen, don't rush. So I'm going to go ahead and decant this. And then if you look at your directions, after we've done 2 distilled water rinses, we're going to do one last rinse with acetone. And we're supposed to use 10 mils. I'm pretty good at visualizing that. If we were in class, you would measure some out. But once again, what the acetone does is it helps this dry more quickly. If there's any water in here, it will mix with the acetone and be more likely to evaporate as well. So I do not want to mix that. I don't put the acetone or the copper nitrate down the drain. So I'll just decant into this petri plate. So now I have my clean acetone and distilled water rinsed silver crystals. And now I'm going to leave these for 48 hours. I'm not weighing this yet. Right now I have wet silver crystals. And when things are wet, they weigh more. So I'm not going to get a realistic mass. So for those of you who answered that last question, that you're leaving it for 48 hours to dry out, you were correct. So if you were doing this in person, you would come back in 2 days and measure it. I am going to give you that information in a couple of days after I've let this sit. So do make sure that you have these masses written down before you leave the video. And you also probably are going to want to write down the initial chemical reaction. It's not balanced, but you will be able to balance it yourself. And we'll talk some more about this in class. Thank you. I'll take this off so I can actually see over here to stop my video, but I will see you in class.